All right, so here we're going to factor polynomials by greatest common factor. It's also called undistribute. This is not a mathematical technical term, but it is a way of thinking about what we're doing here. Quick, we're going to review the divisibility rules to make it a little bit easier for us to work. So how do you know if something is divisible by 2? It's even. In other words, it ends in 0, 2, 4, 6, 8. Threes. This is where you add up all the digits, and if the sum of the digits is divisible by 3, so is the number. Fours. We just look at the last two digits. If the last two digits are divisible by 4, so is the whole big number. For fives, ends in a 0 or a 5. For sixes, it's even, and if you add up all the numbers, it's divisible by 3, the sum. And then nines, add up all the digits, and if all the digits added up is divisible by 9, so was the big number. So, quick reminder also, factors of a number are also called divisors. So we can say greatest common factor, or we can say greatest common divisor here. All right, let's get into some examples. Example number 1 here. 21w plus 28, we are going to factor or undistribute. So we are looking for the biggest number that divides both 21 and 28. So that's going to be a 7. So here we go. We got 7. And then we're going to divide out or undistribute or factor out the 7 from our original expression. So here we go. So 7 times what makes 21w? That's going to be 3w. Another way of saying that is 21 divided by 7. So here we go. We can also do that. 28 divided by 7. 7 times what makes 28? That's going to be a 4. Another example. Here we go. Looking for the biggest number that divides x squared and 7x. Well, we don't have any numbers that do, but we do have variables. So variable that divides both x squared and 7x, well, that's going to be an x. And then times what gives us x squared plus 7x. So x times what gives us x squared? X times x gives us x squared. And then x times what gives us 7x? X times 7. So that's undistribute or factoring. We can multiply this back out. X times x, x squared. X times 7, 7x. Here we go. We're going to factor y to the 7th plus 5y cubed, or to the 3rd power. So what number divides them both? There's no number that divides them both. Again, with any of these, we like to break it up into smaller chunks. Look at the numbers first. Now we're going to look at the variables. How many y's divide both the y to the 7th and y to the 3rd power? That's going to be y to the 3rd. So we do need to use our properties of exponents here. So y cubed times how many more y's to make y to the 7th? That's going to be 4 y's to make that y to the 7th. Another way again is division. Y to the 7th divided by y to the 3rd power gives us y to the 4th power. This would be the quotient property. When you're dividing with exponents and you have the same base, you subtract the exponents. So here we go. Here we're going to remove 3 y's, 3 factors of y from the 5y cubed. Again, think division, or y cubed times what gives us 5y to the 3rd. That's going to be just a plus 5 there. Here we go. 3z squared minus 18z. We're going to factor. We're using greatest common factor or undistribute. So what number divides both the 3 and the 18? Well, that's going to be 3. 3 divides both. Now let's also look at the variables. So we have a z squared and a z. Which variable divides both? That's going to be a single z. So we're ready to figure out what we multiply by 3z to get this one up here. Again, we're thinking undistribute. 3z times what gives us 3z squared? We need another z there. Or we're going to remove one factor of z from the 2 that are already up there, leaving us with 1. And then 3z times what gives us a negative 18z? Well, that's going to be a negative 6. 3 times 6 gives us 18, or 18 divided by 3. We're dividing out or factoring out a factor of 3. Here we go. What two numbers divide both the 42 and the 48? and that's going to be a 6. 6 divides both 42 and 48. Looking at the numbers first, now we'll look at the variables. How many x's divide both the x to the 8th and the x to the 5th? Well, that's going to be 5 factors of x. So we're going to remove the 6 from the 42. That leaves us with a 7. And again, we're thinking division, or 6 times 7 equals 42. And then we're going to remove or divide out 5 factors of x from the 8 factors of x up here. And that's going to leave us with 3 factors of x. And then 6 times 8 makes 48. So we get an 8 there. And then x to the 5th times no more x's to make x to the 5th. Here we have a trinomial, so we're going to be looking at 3 different terms between the 10y to the 7th, a negative 6y to the 8th, and a positive 22y to the 7th. So again, start out with the numbers. What number divides both the 10, the 6, and the 22? Well, that's there. It's even, so that's going to be a 2. And now let's look at variables. What variable, or how many y's divide into the y to the 10th, y to the 8th, and y to the 7th? That's going to be a y to the 7th. So set up our parentheses here, divide out the 2 from the 10 for our number here, and that's going to be 5. 2 times 5 makes 10. We have y to the 7th. How many more y's do we need to get y to the 10th? Well, we're going to need 3 more y's, so y to the 3rd. Negative 6 divided by 2 goes here. We know that's going to be a negative 3. And then y to the 7th times how many more y's to get y to the 8th? We only need 1 more y, so we just leave it as minus 3y. And then 22 divided by 2 goes here, and that's going to be an 11. And we don't need any variables here. Y to the 7th times no more y's gives us y to the 7th. Here's a quick helpful hint. When we have 3 terms, in this example here, x to the 3rd, x to the 6th, and x to the 4th, our greatest common factor of those different terms is going to be the one with the smallest exponent. So between these 3 here, that's going to be the x to the 3rd would be the greatest common factor. So remember, anytime we're finding the greatest common factor, we're looking for the number that divides them both first, and then we do the variable that divides them both next, and that goes there. And then we're thinking division for our parentheses, or 3z times what to make 3z squared.